Now in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that side AD equals to side BC. We also know that this angle ABC equals to 30 degrees. This angle ACB equals to 100 degrees. And we want to find out the value of this angle ADC. So we'll start with the first method. In the first method we will define side AC of triangle ABC as A, that is to say the length of side AC is A units, and we will also define side BC of triangle ABC as B, that is to say it equals to B units in its length. And we actually know that AD equals to BC. We know that AD equals to BC, it is given us in the question, but according to our definition, BC equals to B units. BC equals to B units. From this equation, we will derive that AD also equals to B units. AD equals to B units. In the next step, I will present to you a new law, that is the law of sines. The law of sines is true in any triangle. So you can write down that in any triangle, so actually if we have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side BC of triangle ABC equals to A units in its length. This is angle A. Side AC of triangle ABC equals to B units in its length. This is angle B. Side AB of triangle ABC equals to C units in its length. This is angle C. According to the law of sines, A over sine A equals to B over sine B. Equals to C over sine C. Okay, and this formula is true in any triangle. Again, capital A, capital B, and capital C are the angles of triangle ABC, or the sizes of the angles in triangle ABC. A, B, and C, small a, small b, are the length of triangle ABC sides. Okay, so from this formula we will derive that A over sine A equals to B over sine B So actually I will copy triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. Okay. So this is triangle ABC that I copied from the original drawing. We know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC, the sum of its angles must be equal to 180 degrees. That is to say, we define the missing angle as angle X. So angle X plus this angle that is 100 degrees plus this angle that is 30 degrees must be equal to 180 degrees. So here we will subtract 130 degrees from this equation, and we will get that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that angle X equals to 50 degrees. We will substitute angle X by 50 degrees. Now we can implement the law of sines in this triangle ABC. According to the law of sines, we will get that A over sine 30 degrees will be equal to B over sine 50 degrees. So here we will divide this equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Again, according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay? In the next step, I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. But we have already found out that angle BAC, this angle equals to 50 degrees. So if we define angle BAD as theta, then angle AC must be equal to 50 degrees minus theta, because of the fact that the sum of those two angles must be equal to 50 degrees. So if this angle DAB is theta, angle DAC must be equal to 50 degrees minus theta in order to complete the sum of the angles to 50 degrees. That is to say, 50 degrees minus theta plus theta equals to 50 degrees. And we will find out the value of the angle ADC, the angle that we are looking for. So we will define this angle as angle Y, and we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So in triangle ADC, we will get that 50 degrees minus theta, this angle, plus 100 degrees, plus this angle, that is angle Y, must be equal in total to 180 degrees. Here we will subtract 150 degrees from this equation, and we will get that minus theta plus Y equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add theta to this equation, and we will get that angle Y equals to 30 degrees plus theta. Okay, so we will substitute angle Y by 30 degrees plus theta. So the angle that we are looking for equals to 30 degrees plus theta. Now I will copy this triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. Okay? So actually, this is triangle ADC that I copied from the original drawing, and we will implement the law of cosines, the law of sines in this triangle ADC. So according to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sine 100 degrees. So here we will divide this equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that A over B equals to sine 30 degrees plus theta over sine 100 degrees. Okay, so we actually have two equations for A over B. According to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. And according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. I repeat again. According to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees, and according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. Here we will create equation number 3 that states that A over B, according to equation number 1, must be equal to A over B according to equation number 2. Okay, so according to equation number 3, A over B according to equation number 1 equals to sine 30 degrees over sine 50 degrees, and it must be equal to A over B according to equation number 2, and A over B according to equation number 2 is sine 30 degrees plus theta over sine 100 degrees. So here we will cross multiply equation number 3, and we will get that sine 30 degrees, actually sine 30 degrees is 1 over 2, so 1 over 2 times sine 100 degrees must be equal to sine 30 degrees plus theta over sine, it is actually sine 30 degrees plus theta times sine 50 degrees, because we cross multiply the equation number 3 here. Now we will use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a and according to this trigonometric identity that sine 2a equals to 2 sine a cosine a, we will get that sine 100 degrees equals to 2 sine 50 degrees cosine 50 degrees. So sine 50 degrees times cosine 50 degrees that equals to sine 30 degrees plus theta times sine 50 degrees. Okay, so here we have 2 over 2 is 1, 2 will get cancelled, and we have sine 50 degrees on both sides of the equation, equation number 3, so sine 50 degrees also will get cancelled. So what is left after we cancel sine 50 degrees? What is left, it is actually according to question number 3, cosine 50 degrees so according to question number 3, we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. Okay, I'll repeat again. According to equation number 3, we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. Here we will use the trigonometric identity that states that sine cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus alpha is 50 degrees. So we got that cosine 50 degrees equals to sine 90 degrees minus 50 degrees according to this trigonometric identity. So we got actually that cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees, so it is sine 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. So now we can substitute cosine 50 degrees in this equation, equation number 3, by sine 40 degrees. So we'll do it now, and we will get that according to equation number 3, cosine 50 degrees, it is actually sine 40 degrees, and sine 40 degrees equals to sine 30 degrees plus theta. Okay, we found out that sine 40 degrees equals to sine 30 degrees plus theta. From this equation we will derive that 40 degrees equals to 30 degrees plus theta. Here we will subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we actually found out that angle theta equals to 30 degrees. And the angle that we are looking for is angle ADC, but angle ADC equals to 30 degrees plus theta. 30 degrees plus theta, and theta is 10 degrees, so 30 degrees plus 10 degrees is 40 degrees. So we actually found out that the value of angle ADC is 40 degrees. So angle ADC, that equals to 30 degrees plus theta, will be equal to 30 degrees plus 10 degrees because of the fact that theta equals to 10 degrees. So 30 degrees plus 10 degrees is 40 degrees. Okay? So angle theta equals to 40 degrees according to the first method. In the next step I will present to you how to find out the value of angle theta according to the second method. In the second method, we will do a construction. We will extend side BC by a straight line. And then from point A, we will draw perpendicular to the extended BC. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point between the perpendicular from point A and the extended BC as point E. And actually, we know that BC is a straight line because of the fact that it's one side of triangle ABC, and we extended the straight line BC by a straight line, therefore BE will be still a straight line. So, we know that BE is a straight line. I will write it down. Line segment BE is a straight line. So line segment BE is a straight line, and we have the rule that you can see line segment BE is a straight line, and we have the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees. So if we define angle ACE as angle Y, we will get that at point C on the upper side of the straight line BE, the sum of the angles must be equal to 180 degrees. So this angle, that is angle Y, plus this angle that is 100 degrees, in total the sum of those two angles must be equal to 180 degrees. Angle Y plus 100 degrees must be equal to 180 degrees. Here we subtract 100 degrees from this equation, and we get that angle Y equals to 180 degrees minus 100 degrees equals to 80 degrees. So we found out that angle Y equals to 80 degrees. You can write here down that angle Y equals to 80 degrees. And we will actually define BC as A. BC equals to A units in its length. Okay, BC equals to A units in its length. And it is given us in the question that AD equals to BC, and according to our definition, BC equals to A units. BC equals to A units, and so from this equation, we will derive that AD also equals to A units. AD equals to A units. So we can write here that AD equals to A units. In the next step, we will focus on the right triangle, triangle ACE. The right small triangle, triangle ACE. On the right small triangle, triangle ACE, we know that tangents 80 degrees. First of all, we will define side AE as Y, and we will define line segment CE, this line segment, as X. So in the right triangle, triangle ACE, we know that tangents 80 degrees tangents 80 degrees equals to AE over CE. I'll repeat again. In the right triangle, triangle ACE, we know that tangents 80 degrees equals to AE over CE. But AE equals to Y according to our definition, so we'll substitute AE by Y. And CE equals to X according to our definition. We will substitute CE by X. So in conclusion, we found out that in triangle ACE, tangent 80 degrees equals to y over x. Here we will multiply equation number 1 by x, and we will get that according to equation number 1, y equals to x tangent 80 degrees. I repeat again, according to equation number 1, y equals to x times tangent 80 degrees. So in the next step, we will focus on triangle ADE, on the right triangle ADE. So on the right triangle ADE, first of all, we will define the angle that we are looking for, that is to say, angle ADC as angle theta. So, in the right triangle ADE, we will get that sinus theta equals to AE over AB. Sinus theta equals to AE over AB, but we will actually take on the right triangle ADE. We know that tangent theta equals to AE over DE, or it is actually sinus theta equals to AE over AD. Sinus theta equals to AE over AD. I'll repeat again. On the right triangle ADE, we know that sinus theta equals to AE over AD. AE equals to y according to our definition, and AD equals to A also according to our definition. So we actually found out that sinus theta equals to y over A, I repeat again, in the right triangle ADE, sinus theta equals to y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we will get that A equals to y over sinus theta according to equation number 2, a equals to y over sinus theta. But according to equation number 1, y equals to x tangents 80 degrees. So we substitute y by x tangents 80 degrees in equation number 2. And we will get that a will be equal to y is x tangents 80 degrees over sinus theta. So actually, we found out that a equals to x tangents 80 degrees over sinus theta. And according to equation number 1, y equals to x tangents 80 degrees. Now we'll focus on the right triangle, triangle ABE, on the right big triangle, triangle ABE. On the right big triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. Okay, in the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. But according to our definition, AE equals to y. AE equals to y. And the value of BE, it is actually A plus X. Again, BE equals to A plus X. So actually, according to equation number 3, tangents 30 degrees equals to y over a plus x. I repeat again, according to equation number 3, tangents 30 degrees equals to y over a plus x. Here we will substitute y by x tangents 80 degrees from equation number 1, and we will substitute a by x times tangents 80 degrees over sinus theta from equation number 2. So we'll do it now, and we will get that tangents 30 degrees according to equation number 3 equals to y is x tangents 80 degrees according to equation number 1 over a plus x, and a according to equation number 2 is x tangents 80 degrees over sinus theta, and here we have also plus x. So here we will actually multiply x by sinus theta, and then we will divide it by sinus theta. In this way we will have a common factor with this expression. Okay, so x, it is actually x times sinus theta over sinus theta, it is actually x. So here we will move sinus theta from the denominator to the numerator in this expression, expression number 3, or equation number 3, and we will get that according to equation number 3, tangents 30 degrees equals to x tangents 80 degrees times sinus theta over x tangent 80 degrees plus x sinus theta. So here according to question number 3, we got this expression x tangent 80 degrees times sine theta equals over x 80 degrees plus x sine theta equals to tangent 30 degrees. So here we have x in the numerator and x also in the denominator, so x will get cancelled. We know that tangent 30 degrees is 1 over square root of 3 units, so I write it down. That equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Okay, so here we will cross multiply this equation, equation number 3, and we will get that according to equation number 3, tangent 80 degrees plus sinus theta equals to tangent square root of 3 times tangent 80 degrees times sinus theta. Here we will subtract sinus theta from this equation, equation number 3, and we will get that tangent 80 degrees equals to square root of 3 tangent 80 degrees sinus theta square root of tangent 80 degrees times sine theta minus sine theta because we subtracted sinus theta. Here we will take sine theta as a common factor from this side of equation number 3, and we will get that tangent 80 degrees equals to, so sine theta was taken as a common factor, sine theta inside the brackets from this expression we will have square root of 3 times tangent 80 degrees, and what is left from minus sinus theta after we took sinus theta from it as a common factor, what is left? It is actually minus 1. So here we will divide this equation, equation number 3, by square root of 3 times tangent 80 degrees minus 1, and we will get that sinus theta, according to equation number 3, equals to times 80 degrees so the theta equals to times 80 degrees over square root of 3 times tangent 80 degrees minus 1 so now we know that tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees, so we substitute tangent 80 degrees both in the numerator and in the denominator by sine 80 degrees over cosine 80 degrees. So we'll do it now, and we'll get that according to equation number 3, sine theta equals to tangent 80 degrees is sine 80 degrees over cosine 80 degrees and we also have to divide it by square root of 3, and here we have tangent 80 degrees, and tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. So actually we have here cosine 80 degrees in the numerator and cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. What is left from equation number 3 after we cancelled cosine 80 degrees? What is left, it is actually in this side of the equation we have sinus theta, and in the other side of the equation we have sinus 80 degrees over square root of 3. So here actually I forgot the minus 1, so actually minus 1 is equal to minus cosinus 80 degrees over cosinus 80 degrees, so here we must multiply it by minus cosine 80 degrees. So here we have, in the denominator we have square root of 3 times sine 80 degrees minus cosine 80 degrees okay. So here we will multiply the denominator on this side of equation number 3 by 2, and then we will divide it by 2, and we will get that according to equation number 3, sine theta equals to sine 80 degrees over, we will multiply the denominator by 2, and then we divide every expression by 2 in the denominator. So it will be 2 times sine 80 degrees over 2 square root of 3 over 2 minus cosine 80 degrees over 2. So I repeat again. here we actually multiplied this denominator by 2 and then we divide it by 2. So we change nothing. Okay? So we get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times, here we have sinus 80 degrees and square root of 3 over 2 is cosine 30 degrees. And 1 over 2 minus sine 1 over 2 is sine 30 degrees times cosine 80 degrees. Okay. And actually the expression in the denominator of equation number 3 is very similar to the trigonometric identity of sine A times cosine B minus sine B cosine A equals to sine A minus B. In our specific expression, A equals to 80 degrees and B equals to 30 degrees. So actually we will substitute the expression in the denominator by the sine A minus B, and A equals to 80 degrees and B equals to 30 degrees. So we actually substituted sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees by sine 80 degrees minus 30 degrees, because it is true according to the trigonometric identity that sine A cosine B minus sine B cosine A equals to sine A minus B. Okay? So according to equation number 3, we will get that sinus theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we got that according to equation number 3, sine theta equals to sine 80 degrees over 2 sine 50 degrees. And according to the trigonometric identity, that sine alpha equals to sine to cosine 90 degrees minus alpha, we will get that sine 50 degrees it is actually equals to cosine 90 degrees minus 50 degrees. Okay, sine 50 degrees equals to cosine 90 degrees minus 50 degrees. So sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So in conclusion, we found out that that sine 50 degrees equals to cosine 40 degrees. So we actually can substitute sine 50 degrees by cosine 40 degrees according to this equation. So we'll do it now, and we will get that according to equation number 3, sine theta equals to sine 80 degrees over 2 sine cosine 40 degrees. So we substitute sine 50 degrees by cosine 40 degrees. So it will be 2 cosine 40 degrees. So in conclusion, we found out that according to equation number 3, sine theta equals to sine 80 degrees over 2 cosine 40 degrees. Okay, I'll repeat again. We actually found out that sine theta equals to sine 80 degrees or 2 cosine 40 degrees. We will use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. Repeat again, we use this trigonometric identity that states that sine 2a equals to 2 sine a cosine a, and we get here that sine theta equals to, here sine 80 degrees is 2 sine 40 degrees cosine 40 degrees, all divided by 2 cosine 40 degrees. So 2 over 2 is 1, so 2 will get cancelled. We have cosine 40 degrees in the numerator and cosine 40 degrees in the denominator, so cosine 40 degrees will also get cancelled, and we left only with sine theta that equals to sine 40 degrees. So if sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. theta equals to 40 degrees. So we actually found out that the angle that we are looking for, this angle, angle ADC, that equals to theta, equals to 40 degrees. So this angle equals to 40 degrees. You can write here that the angle that we are looking for, that is actually angle ADC, that equals to angle theta, equals to 40 degrees. So in both methods, we found out that the value of angle ADC is equal to 40 degrees. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of angle ADC. In the first method, the value of this angle, angle ADC, and in the first method, I presented to you the law of sines. What is the law of sines? The law of sines is true in any triangle. So if we have triangle ABC, you know that the length of side AB is C units, the length of side AC is B units, and the length of side BC is A units. This is angle A, this is angle B, and this is angle C. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. From this formula we will conclude that A over sine A equals to B over sine B. Then I copied triangle ABC, this triangle ABC, in a new page, and we implemented the law of sines in this triangle, triangle ABC. So actually, this is triangle ABC. It is given us in the question that angle ABC, this angle is 30 degrees, angle ACB is 100 degrees, and this angle is the emissive angle. So we defined this angle as angle X. We know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, the sum of its angles must be equal to 180 degrees. That is to say, this angle, that is angle X, plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we got that 180 degrees minus 130 degrees is 50 degrees. So we found out that this angle equals to 50 degrees. Angle BAC equals to 50 degrees. And we defined AC as A and BC as B. So according to the law of sines, we will get that A over sine 30 degrees, A over sine 30 degrees equals to B over sine 50 degrees. Okay? I repeat again. According to the law of sines, A over sine A over sine 30 degrees equals to B over sine 50 degrees. In this triangle, triangle ABC. A over sine 30 degrees equals to B over sine 50 degrees. Here we divided this equation number 1 by B, and then we multiplied by sine 30 degrees, and we got that A over B equals to sine 30 degrees over sine 50 degrees. I repeat again, according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay? Then I copied this triangle, triangle ADC, in a new page, and we analyzed triangle ADC. Actually implemented the law of sines in this triangle, triangle ADC. But first of all, we have already found out that angle BAC, this angle, equals to 50 degrees. So if angle BAC equals to 50 degrees, and we will define this angle BAD is theta, then angle DAC, this angle must be equal to 50 degrees minus theta in order to complete the sum of those two angles to 50 degrees, because we know that this angle equals to 50 degrees. So this angle must be equal to 50 degrees minus theta, because 50 degrees minus theta plus theta will give us 50 degrees, that is the value of angle BAC. So actually angle DAC, this angle equals to 50 degrees minus theta. This angle equals to 100 degrees, it is given us in the question. This is the missing angle, the angle that we are looking for. So if we will define this angle as angle Y, then we will get that 50 degrees minus theta plus angle Y plus 100 degrees must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we got that 180 degrees minus 150 degrees is 30 degrees. And in this side of the equation we have only minus theta plus y. So here we added theta to this equation, and we got that angle y equals to 30 degrees plus theta. So we found out that this angle equals to 30 degrees plus theta. After we found out the values of all three angles in triangle ADC, we copied triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. Okay, and here this is triangle ADC that I copied from the original drawing. We know that angle DAC equals to 50 degrees minus theta. This angle is 100 degrees. It is given as the question, and we just right now found out that angle ADC, the angle that we are looking for, equals to 30 degrees plus theta. AC equals to A units according to our definition. And according to our definition, BC equals to B. I'll repeat again. BC equals to B units according to our definition, but according to what is given us in the question, BC equals also to AD. BC equals to AD. From this equation, we will derive that AD also equals to B. AD equals to B. Therefore, we can write here that AD equals to B and AC equals to A according to our definition. Okay? Now, we implemented the law of sines in this triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta, A over sin 30 degrees plus theta, must be equal to B over sine 100 degrees. B over sine 100 degrees. Here we divided this equation number 2 by B, and then we multiplied by sine 30 degrees plus theta, and we got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. Okay? So we created here two equations. According to equation number 1 that we created, A over B equals to sine 30 degrees over sine 50 degrees, and according to equation number 2 that we created just right now, A over B equals to sine 30 degrees plus theta over sine 100 degrees. So we created then equation number 3 that states that A over B, according to equation number 1, must be equal to A over B according to equation number 2. Okay? So, according to equation number 3, A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees. And it must be equal to A over B according to equation number 2, that is actually sine 30 degrees plus theta over sine 100 degrees. Here we multiply this equation, equation number 3. We know that sine 30 degrees is 1 over 2. So it is 1 over 2 times sine 100 degrees. That equals to sine 30 degrees plus theta times sine 50 degrees. Okay, then we used the trigonometric identity that sine 2a equals to 2 sine a cosine a in order to simplify sine 100 degrees. So according to this trigonometric identity, we will get that sine 100 degrees equals to 2 sine 50 degrees times cosine 50 degrees, and it equals to sine 30 degrees plus theta times sine 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled. We have sine 50 degrees in this side of equation number 3, and we have sine 50 degrees on the other side of equation number 3. So sine 50 degrees will get cancelled, and we left only with the equation number 3 that states that cosine 50 degrees equals to sine 30 degrees plus theta. Then we use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine 50 degrees must be equal to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So cosine 50 degrees equals to sine 40 degrees. Therefore, we actually can substitute cosine 50 degrees in this equation by sine 40 degrees. We did it, and we got that sine 30 degrees equals to sine 30 degrees plus theta. It means that 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation, equation number 3, and found out that angle theta equals to 10 degrees. Angle theta equals to 10 degrees. Angle theta equals to 10 degrees, but the angle that we are looking for is angle ADC, and angle ADC equals to 30 degrees plus theta. Angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. So angle ADC equals to 30 degrees plus theta, that is 10 degrees. That is to say, angle ADC equals to 40 degrees. 30 degrees plus 10 degrees is 40 degrees. So we found out that the value of angle ADC according to the first method is equal to 40 degrees. The angle that we are looking for is angle ADC, and then angle ADC equals to 40 degrees according to the first method. Then I presented to you how to find out the value of this angle, angle ADC, according to the second method. In the second method, we did a construction. In the second method, we did a construction. We extend that line segment BC by a straight line, and then from point A we drew perpendicular to the extended BC. So this angle is 90 degrees and this angle is 90 degrees. And we defined the intersection point between the perpendicular from point A and the extended BC as point E. And then we calculated the value of angle ACE, this angle. We know that BC is one side of triangle ABC, therefore it must be a straight line. We extended the straight line BC by a straight line, so BE will be still a straight line. And we have the rule that the sum of the angles from one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So if at point C on the upper side we have 100 degrees plus this angle that is the missing angle, we define this as angle Y, must be equal to 180 degrees. First of all, we know that BE is a straight line, and the sum of the angles from one side of a straight line equals to 180 degrees. So at point C on the upper side of the straight line BE, we have angle Y plus angle that equals to 100 degrees. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that this angle Y equals to 80 degrees. Then we focus on this right triangle, triangle ACE. On this right triangle, we know that tangents 80 degrees equals to AE over CE. In the right triangle ACE, tangents 80 degrees equals to AE over CE. AE equals to Y according to our definition, CE also equals to X according to our definition. So in conclusion, we found out that in triangle ACE, tangents 80 degrees equals to Y over X. Here we multiply this equation number 1 by X, and we found out that Y equals to X tangents 80 degrees. Then we focused on the right triangle, triangle ADE. This right triangle, triangle ADE. Here we know that if we define angle ADE as theta, then in the right triangle, triangle ADE, we will get that sinus theta equals to AE over AD. In the right triangle, triangle ADE, we know that sinus theta equals to AE over AD, but AE equals to Y according to our definition, and AD also equals to A. We found out that AD equals to A. So in conclusion, we found out that in triangle ADE, sinus theta equals to Y over A. Here we multiplied this equation number 2 by A, and then we divided by sinus theta, and we got that A equals to Y over sinus theta, but Y equals to X tangents 80 degrees according to equation number 1. So we substitute Y by X tangents 80 degrees here, and we found out that A equals to Y is X tangents 80 degrees over sinus theta. That is the value of A. The value of Y according to equation number 1 is X tangents 80 degrees. Then we focus on the right triangle, triangle ABE, the big right triangle, triangle ABE. Here we know that tangents 30 degrees equals to AE over BE. In the right triangle, triangle ABE, tangents 30 degrees equals to AE over BE. AE equals to Y. And what is the value of BE? BE equals to A plus X. So in conclusion, we found out that in triangle ABE, tangents 30 degrees equals to Y over A plus X. Tangents 30 degrees equals to Y over A plus X. Then Y equals to X tangents 80 degrees, and A equals to X tangents 80 degrees over sinus theta. So we can substitute A and Y by the values that we found in equation number 1 and equation number 2. We did it, and we got that tangents 30 degrees equals to Y. Y is X tangents 80 degrees, and over A plus X. And A, according to equation number 2, is equal to X tangents 80 degrees over sinus theta plus X. And X, we multiplied X by sinus theta, and then we divided by sinus theta in order to have a common factor with this expression. So in conclusion, we got this expression. Here we can move sinus theta in the denominator. So we did it, and we got that tangents 30 degrees equals to X tangents 80 degrees times sinus theta over X tangents 80 degrees plus x sinus theta. Here we have x in the numerator and we have x in the denominator, so x will get cancelled, and we got that tangent 30 degrees is 1 over square root of 3 units. So in the other side of the equation we have tangent 80 degrees times sinus theta over tangent 80 degrees plus sine theta. So here we cross multiply this equation, equation number 3, and we actually got that here tangent 80 degrees, we cross multiply this equation, equation number 3, and we got that tangent 80 degrees plus sine theta equals to square root of 3 times tangent 80 degrees times sine theta. Here we subtracted sine theta from this equation, equation number 3, and we found out that tangent 80 degrees equals to square root of tangent 80 degrees times sine theta minus sinus theta. Here we took sine theta as a common factor from this side of the equation number 3, and we got that tangent 80 degrees equals to sine theta as a common factor, and inside the brackets we will get from this expression, we will have square root of 3 times tangent 80 degrees, and what is left from minus sine theta after we took from it sine theta as a common factor, what is left, it is actually minus 1. Okay, then we divided this equation, equation number 3, by square root of 3 times tangent 80 degrees minus 1, and we got that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. Okay, and then we know that tangent 80 degrees equals to sinus 80 degrees over cosinus 80 degrees, so we substituted tangent 80 degrees by sine 80 degrees over cosine 80 degrees. We did this in the numerator, and we also did the same thing with the denominator. Tangent 80 degrees equals to sine 80 degrees over cosine 80 degrees, and we also must multiply it by square root of 3, and minus 1, we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees in order to have a common factor with this expression. And here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and what is left after we cancelled cosine 80 degrees from equation number 3, what is left here, sine theta equals to sine 80 degrees over square root of 3 times sine theta minus cosine 80 degrees. So here we actually multiplied the denominator by 2, and then we divided it by 2. So we multiplied the denominator by 2, and then we divided it by 2. So from square root of 3 we got square root of 3 over 2, and here we had cosine 80 degrees, and we divided cosine 80 degrees by 2, so we got minus cosine 80 degrees over 2. Then we got that sine theta equals to sine 80 degrees over 2 times, we substituted square root of 3 over 2 by cosine 30 degrees, because of the fact that cosine 30 degrees equals to square root of 3 over 2, minus sine, we substituted 1 over 2 by sine 30 degrees, and we got sine 30 degrees times cosine 30 degrees. The expression sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. Actually, we can substitute this expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we did it, and we got that sine theta equals to sine 80 degrees over 2 times, and we substituted this expression by sine A minus B, that is actually sine 80 degrees minus 30 degrees. So we got that sine theta equals to sine 80 degrees equals to sine 80 degrees over 2 times 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we got that sine, according to equation number 3, sine theta equals to sine 80 degrees over 2 sine 50 degrees. And we use the trigonometric identity that sine alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. So sine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. And here we have sine theta equals to sine 80 degrees, and here we substituted sine 50 degrees by cosine 40 degrees because of the fact that we found out that sine 50 degrees equals to cosine 40 degrees. So we got this expression that sine theta equals to sine 80 degrees over 2 cosine 40 degrees, and we use the trigonometric identity that states that sine 2 theta equals to 2 sine theta cosine theta. So sine theta equals to sine 80 degrees, and sine 80 degrees according to this trigonometric identity will be equal to 2 sine 40 degrees cosine 40 degrees over cosine 40 degrees. We have cosine 40 degrees in the numerator, and we have cosine 40 degrees in the denominator. 2 over 2 is 1. So in conclusion, we found out that sine theta equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. So we found out that the angle ADC that equals to theta, it is actually equals to 40 degrees. If angle ADC that equals to theta, it is actually equals to 40 degrees. So in both methods, we found out that angle theta or angle ADC equals to 40 degrees. Okay, thank you very much.